We see tons of stars in the sky in a given night. For those of you who live in a city inundated by light pollution, you should probably just take my word for it. Even though we are so monumentally far from these systems, being those that consist of a star and its planets, as we observe them from Earth, did you know that we can look at any of these stars and locate habitable planets despite our far distance from these planets? As you may know from high school, the composition of a substance can be determined by its density, and density equals mass divided by volume. The same idea can be applied to planets, including those outside of our solar system, which are called exoplanets. Thus, we need methods to find such mass and volume, and they would need to be indirect given that we cannot interact with the exoplanet's matter at our far distance from the planet. To find volume and the planet's orbital radius, which is important for a later step. The Royal Observatory Greenwich states that the transit detection method can be used as an object moving in front of a star blocks some of the star's light, giving us a periodic graph of brightness over time in which the depth of the drops in brightness is proportional to the planet's radius, allowing us to find the planet's volume and, according to HabWorlds, an aggregator of planet's habitability information, the periodicities of these drops allow us to find the planet's orbital radius via Kepler's third law. According to the Planetary Society, a space exploration group started by famed astronomers Carl Sagan, Louis Friedman, and Bruce Murray, the radial velocity method can be used to determine the planet's mass, as the gravitational tug of the planet on its parent star can cause the star to wobble opposite the direction that the planet is orbiting, which we can perceive from Earth as a redshift of the star as the star moves away from us and a blue shift of the star as the star moves toward us. And such wobble allows us to find the planet's radial velocity, which is proportional to the planet's mass. Of course, these methods are not without their limitations. For example, according to the Royal Observatory Greenwich, the transit detection method works best when an exoplanet is large relative to its parent star, and according to the Planetary Society, the radial velocity method works best when the orbital plane of the exoplanet's planetary system appears edge-on when observed from the Earth. But such detection methods are still highly useful to discovering potentially habitable exoplanets. As previously stated, by knowing the density of the exoplanet, we can determine the probable makeup of the planet's composition, and according to astrobiologist Dr. Brittney Schmidt and planetary geomorphologist Heather Chilton, along with whether the planet is located within its system's habitable zone, which can be found using the planet's orbital radius via the transit method, and also the indirectly measured star's mass, thus whether the planet contains the necessary ingredients for habitability. By finding potentially habitable planets, our chances at finding extraterrestrial intelligent life, or even just planets to inhabit, in other words, the chance for humanity to persist past the lifespan of our planet's ability to sustain life, stunted by our stubborn use of CO2 emitting fuels, increases. To conclude, by looking at the starry night sky, we can save the human race.